So there will be n branches or n curves of the root locus. And as k tends to infinity, m of these branches will terminate at an open loop 0. The remaining n minus m curves or branches will go to, essentially n minus m branches will go to infinity along what are called asymptotes, right? That's what we learned yesterday, right, as a first step. Okay, but then now what do we do, right? So if you look at going forward, what are the subsequent steps, right? As far as the construction of the root locus is concerned, right? So that's what we'll be looking at in today's class, right? So let's look at the second step, which is to figure out which portions of the real axis, lie on the root locus. Okay, so let's first read the step. Then we will go to the handwritten notes, and then I will explain the logic behind this step. So if you and I want to locate the portion of the real axis that lie on the root locus, what we do is that we take a test point on the real axis. If the number of real open loop poles and real open loop zeros to the right of the test point is odd, then the point lies on the root locus. Okay, so that is the second step. So what is the logic behind this? So let's go here, right? So now we, so once again, I'm going to explain things using the example that you and I are studying. So in our example, if you look at the real axis, we have one pole at the origin, one pole at -4, right? There are no open loop poles on the real axis. Okay, so we can immediately observe that this entire real axis is split into 3 regions. Okay, the first region is from -infinity to -4. The second region is from -4 to 0. The third region is from 0 to infinity. Okay, so we look at the real axis alone. Okay, so we look at the regions created by real open loop poles and real open loop zeros. In this particular example, there are no real open loop zeros. Okay, so that's why we are only dealing with the real open loop poles. Okay, so now let's say we take this test point ST1. Okay, on the real axis. Please note that if I look at the test point, and if I take this test point ST1 and I look at the number of real open loop poles and real open loop zeros to the right of this test point, we can count that there is one real open loop pole at -4, another real open loop pole at 0. So that is 2, right? And that's an even number. By that criteria, we essentially can conclude that the region -infinity to -4 does not lie on the root locus. Why did we have a criteria that the total number of real open loop poles and real open loop zeros should be odd? That is because of the angle condition. So if you recollect, recollect this angle condition, what was the angle condition? Any point which satisfies the the face of the open loop transfer function being an odd multiple of pi, okay, is on the root locus. Now, when we look at the step that we just learned, we see that if I draw a vector, from each open loop pole to the test point ST1, right? What can we say about the angle made by this line? It is going to be 180 degrees. Okay, correct? So if we draw a vector or a line segment from the real open loop pole on the real axis to this test point ST1, The angle made by all the things, both -4 and 0 will be 180. So that's why they add to 360, right? If you add them. But then what you and I want is only an odd multiple of 5, right? So now we can observe why we need the number of real open loop poles and real open loop zeros to be odd. Okay. So I hope this gives us the reason why this condition came. Now, if we take region 2 and then we take the stress point ST2, right, which is in between -4 and 0. Now we look to the right of the stress point, right? How many real open loop poles and zeros we have?
One.
So essentially there is only one, right? Essentially we have only one real open loop pole, and that's an odd number, right? Is it not? Okay. So consequently, we can immediately observe that like we can observe that the point ST2 satisfies the condition, right? The angle condition, and consequently, the region -4 to 0 lies on the root of this. So now we can have a similar argument, right? So if we draw the vector from -4 to ST2, that vector is along the positive real axis, right? The direction, right? So what do you think is going to be the angle of this vector from
zero degree?
This is going to be 0 degree. On the other hand, the one from 0 to ST2 is pointed along the negative real axis. So what do you think will be the angle?
-180.
It will be plus or minus 180. Okay, doesn't matter, right? So consequently, if you add them, we can immediately observe that we are going to get an odd multiple of 180, right? So now I hope this becomes even more clear, right? On why we need an odd multiple. Okay, so that is why the region between -4 to 0 essentially